Hello students, in previous lecture we have studied about the line segment, ray, line, congruent segments, properties of the congruent segments, that is reflexivity, symmetry and transitivity, as well as midpoint of segment and comparison between two different segments and perpendicularity of segments, as well as perpendicular rays, perpendicular lines, perpendicular segments, and the distance of point from a line, which is determined by using property perpendicularity. Then those all concepts which have already learned in previous video or previous lecture. Today we are going to solve few examples from practice set 1.2, which is based on those all concept, that is property of congruent segment, midpoint of segment, perpendicular line, perpendicular segments, perpendicular rays and distance of point which is outside the segment from that given segment, or the distance of point from a line which is outside that line. Then first of all, see here from practice set 1.2, question number 1 is given here. Following table, that table shows points on a number line and their coordinates are given here. Then see here coordinates and points which is given here, the points A, B, C, D and E. These points are given here and their coordinates. See here A having coordinate -3, B having coordinate 5, coordinate of C is 2, coordinate of D is -7 and coordinate of E is 9. And decide whether the pair of segments given below, see here the pair of segments are given in the examples, whether those pair of segments are congruent or not. We have to decide the given pair of segments are congruent or non-congruent. Then using this table in which coordinates of the points are given here, with the help of this we have to decide the given segments are congruent or not. Then first example, segment DE and segment AB. All of you have studied about the distance between 2 points, and the distance between 2 points can be calculated using the coordinates of those points. Taking the coordinates of D and E, we can determine the distance of DE, and the distance of DE is the length of DE, that is the length of DE. Then see here, to determine the length of DE, we have to find out the distance between point D and point E. Then first of all we have to write the coordinates of D, that is here -7, coordinate of E is 9. Then the distance between DE, that is we have to subtract the smaller value or coordinate from the bigger coordinate. Then here 9 is bigger than -7. Therefore, -7 is subtracted from 9. Therefore, 9 minus -7. -7 have to subtract from 9. Therefore, here distance between DE point, that is 9 minus -7, that is 9 plus 7. And here 9 plus 7 is the 16. That means the distance between D and E point is 16. That means therefore length of DE is 16 units. Then using this concept we have to determine the length of AB segment. Therefore, first of all, distance between A and B point we have to determine. That means the length of AB we will get. Then the coordinate of A is -3, coordinate of B is 5, and here -3 is less than 5. That means here 5 is greater number or greater coordinate. Therefore, distance between A and B point, that is length of AB, is equals to, we have to subtract -3 from 5. Therefore, 5 minus -3, that is 5 plus 3. And that is length of AB is 8. Then see here, the length of AB is 8 units. And see here, the length of DE is 16. Here, length of DE is double of the length of AB. That means here in this example, length of DE and length of AB are not the equal. That means here in this example, length of AB is not equals to length of DE. Therefore, AB, segment AB and segment DE are not the congruent segments. These are not the congruent segments. Then one more example that is given here in the question number 1, that is segment BE and segment AD. Second one, that is segment BE and segment AD. Then we have to find the distance between B and E point, that is the length of BE. Length of B. Then see here, coordinate of B is 5 and coordinate of E is here 9, and here 9 is greater than 5. Therefore, distance between B, that is length of B, is 9 minus 5, and that is 9 minus 5, 4. Therefore, length of BE is 4. Similarly, we can determine the value of or length of AD. Therefore, distance between A and D point, that is the length of AD. Therefore, here the coordinate of A is -3 and coordinate of D is -7. And here, see here, the sign of both numbers are negative. Then here minus 3. Therefore here minus 3 is greater than minus 7. Therefore distance AD, that is length of AD, is, we have to subtract minus 7 from minus 3. Therefore minus 3 minus minus 7. Therefore minus 3 minus minus plus 7. Here the sign of 3 is negative sign and sign of 7 is positive. Therefore we have to subtract 3 from 7. And here we get 4. And the sign of greater number, that is plus 4. That means it is a 4. Plus 4, that means 4. Therefore here length of AD is 4. Then see here, length of BE is also 4 and length of AD is also 4. Therefore here length of AD equals to length of BE. Therefore AD congruent BE segment. Therefore those segments are congruent. Then we will solve few more examples from practice set 1.2, that is question number 2. See here, in question number 3 point, in question number 2 the similar examples given which is based on, that is congruent segments as well as the distance of the two different points and the length of different segments. You have to solve this. Then in question number 3, see here, point P is the midpoint of segment CD. That means here the segment CD is given here, of which P is a midpoint. That means here P is a midpoint of segment CD. Therefore here segment CP is equals to or congruent segment PD. That means CP and PD are congruent segments. And here the value of CP, that is 2.5 unit, is given here and we have to find out. Therefore here CP is 2.5 units are given here and we have to find out the value or the distance between C and D point, that is length of CD, we have to determine. Then see here, from given condition and given values we can determine the length of CD. Here length of CD is equals to length of CP plus length of PD, and here CP and PD are congruent segments. Therefore here length of CD is equals to length of CP. The length of CP is given here 2.5 units, and as CP and PD are congruent, therefore value of PD is also 2.5. Therefore length of CD is equals to 5 unit. Then here the length of CD is 5 unit because the length of PD is also 2.5 units. Therefore the distance between C and D point is 5 units. Then we can solve the examples which is given in the practice set 1.2 for more practice. Then here in question number 4, one more example is given which is based on the comparison of segments. And here in this example, AB is given here. That is, AB is 5 centimeter. That means length of AB is 5 centimeter. BP is of 2 centimeter. And AP is of 3.4 centimeter. Then we have to compare between the segments given here. Then see here, AB is 5 centimeter. That means here length of AB is 5 centimeter. Length of BP is 2 centimeter. And length of AP is 3.4 centimeter. Then first of all, we have to write those segments according to ascending or descending form, according to their lengths. Then BP is the smallest one. Therefore, length of BP is 2 centimeter. Then length of AP is 3.4 centimeter. And length of AB is 5 centimeter. Therefore, here, see here, BP is the smaller segment. Then AP is greater than that segment BP, and AB is biggest segment. Therefore, we can compare between those segments by this concept, that is, BP is the smallest segment and AB is biggest segment. That means here AB is greater than AP and AP is smaller than AB, as well as AP is greater than BP and BP is smaller than AP. As well as one more comparison is there, that is, as BP is smaller than AP and AP is smaller than AB, therefore we can write BP is smaller than AB. That is according to the property of transitivity. Then we can solve the examples which is based on properties of rays and the properties of the different properties of the sets. Then question number 5 we have to solve here. Here in question number 5, there is one number line is given here, on which, see here line L is given, on which there are few points are given here, that is point T, S, point S, point R, point P and point Q. Then few questions are asked here according to this number line or according to this given figure which is based on that figure. Then first one question, that is, write the name of opposite ray of ray RP. Then see here, we have to focus on the ray RP first. See here, the ray RP, that is ray RP, that means end point of that ray is R. Therefore, ray RP is here. which is shown by the black colored pen. Then we have to write the opposite ray of that ray RP. Then the opposite ray of RP also have the common endpoint R, and which having the direction opposite to that ray RP. Therefore here ray RT or ray RS is the here ray RT, or we can say ray RS is the opposite ray of ray RP. Then one more question is given here, that state the ray of which segment QR is a subset. See here, we have to again focus on the segment QR. See here, segment QR is given here, and that is shown by the dark color, black color pen, that is segment QR. Then here we have to mention the ray of which the segment QR is a subset. That means that segment QR should be included in that ray, that is set of ray, set of points present on that ray. Then see here, considering the endpoint Q, we have to write the rays here in which segment QR is included in it. Then second question, of which answer is, see here, ray QR, in which the points on that QR segment is included in it. Therefore ray QR, ray QP, ray QP, that we can extend that at infinite point. Here ray QP, ray QS, and ray QT. Ray QT are the rays of which the segment QR is a subset, because the points on segment Q are included in those rays. That is the solution of question number 2 given in the question number 5. Then last one question, that is write the rays with endpoint S. Then see here, focus on the point S here, and we have to write the rays which is started from point S. Then question number 3, of which solution is the ray ST, ray ST, ray SR, ray SP, and ray SQ. Ray SR, ray SP, and ray SQ are the rays with endpoint S. Endpoint S. That is about the few examples which is based on the different properties, that is congruent segments, midpoint of segment, comparison between segments, and perpendicularity of the line segment or line or rays or property of sets from practice set 1.2. Then you should solve the remaining examples from practice set 1.2 for more practice, as well as you can solve the examples which is based on those concept from problem set 1. Thank you.